Okay, welcome to MCO455 Lab 6 and the Lab 6 quiz. One of the things you're going to have to do, which we haven't really had to do anything like this before, we're going to have to cut the red wire on the 4-pin connector to the LCD and connect it to the plus 5-volt connector on the Grow shield. Otherwise, the LCD will not display characters. So let me just show you what that means. So when you take a look here, you can see that the red wire has been cut close to one of the connectors. And so the one that comes here, the red wire that comes here, it comes out to here. Now this is braided wire. So what you're going to have to do is get a piece of 22 gauge wire soldered on there and shove the other end into the connector that's up here that says plus 5 volts. So the shield is going to go on your microcontroller first. You make sure that switch is always at 3.3 volts, because if you run the A to D or anything at 5 volts on that 5-volt thing, you're going to burn up your micro. You're going to fry your microcontroller. So make sure this is on 3.3 volts. So, but that goes on, and then you start plugging things in here. So right now you should have plugged into here on A0, which is this guy. You should have plugged into there already your temperature sensor. Here you should have plugged in your pot, or what it's called, angle sensor, whatever. And then this guy here, this one here goes into any of the I2C connectors that are up here. So these all come with 4-pin connectors. And as I said, what you have to do with this one is break the red wire, because otherwise it's just going to have 3.3 volts going to this. And once you cut the wire close to a connector like this and plug it in, then you're just going to solder it onto a 22 gauge wire and plug that into this little header up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is where you plug it in here. Where we've done the temperature sensor, analog in, all this kind of stuff we've done. Interrupts we're doing this week, including not only the asynchronous interrupts, but the periodic interrupts. And those are all going to be part of your theory quiz this week. And the theory quiz is worth 2%, and the Lab 6 quiz today is worth 1%. Now over here, what you're going to find is under video lectures in your theory section, under week 7, these are the video lectures that you're going to do. I2C and asynchronous and periodic interrupts, plus in your theory section, on week 7, there's also practice quizzes. And what you're going to find is that the practice quizzes that you have here for week 6 and week 7 are going to make up the chapter quiz that you're going to do this week. And just going back here just for a second here, that's what we're talking about here. So chapter 4 quiz is going to be made up of the practice quiz questions here and the practice quiz questions here, but it's going to be done this week in your theory class for 2 periods. There's quite a lot of questions in here, so be prepared for that. So make sure before your theory class that you've gone through all of this material here on both here and here, the practice quizzes, so that you know you're going to be up to speed for that. In Lab 6 here, where there's a little video now about sprintf. So this has changed since it was before, because the version you should have should also have the words and interrupts here. If you do, that is the most current version. So what you're going to do is you're going to create a program called Lab 6. You're going to do all this stuff here. You're going to watch this video. You're going to learn about the Grove underscore LCD underscore RGB backlight class references and all this. And you're going to watch this video to see how the other public member functions work here. And then you're going to click here to bring this particular program into your cloud compiler. And once you bring it in, and there's going to be similar stuff as we'll talk about on your lab quiz, you're going to be bringing stuff in, but just by clicking there, you can actually bring all of this code in so you don't have to type it. So let's take a look at some of the new things that you didn't see before. Before you've done include embed.h, but now you have to include grove underscore LCD underscore RGB underscore backlight.h, and you also have to bring in the library. And it shows you in the video how to do that, how to actually bring in the library. And then it says when you run the program, as you turn your pot, you should see the readings and so forth on a blue background. Let's take a look at some of this code and see if we can figure it out. One of the things that we've not used yet is something called sprintf. And sprintf is here. It says sprintf buffer comment. It could be any name at all. So you can set up here, where did I put it there? Yeah, char buffer. So char Bob, char Fred, char Sally, char anything. I've got the word max up here. And max I've set to 20, so you got 20 elements. But in the video, it's going to show you to reduce that to 16. It's a little overkill because there's only 16 characters per line on your LCD. So what you're going to do first is you're going to go and put zeros in your entire character array to put all nulls in, just to initialize it. Then you got LCD clear. Now the thing is with LCD, where did I put it? There it is. When you're setting this up, you're going to be putting in things like Grove LCD backlight, whatever name you've got here, whether it's LCD capitals, ABC, if it's Bob, Fred, Sally, George, whatever that is, you're going to put the other part here, LCD.clear, LCD.locate. These are your other Grove functions here that you're going to use, like clear and locate. And it doesn't matter, whatever name you've used here, that's the thing that you're going to put in front here. Now sprintf says reading voltage, and when it puts it into here, then you say LCD locate. Now one of the things about the locate command, the first thing here is the column, and column 0 to 15 rather, and this is the row. Rows go 0, which is the top row, and the bottom row, so it goes column and row. And when you say LCD print and buffer, it's going to say reading and voltage. Now reading over here is going to be the raw data. Voltage is going to be this number, which is going to be a number from 0 to 0.99. We'll actually multiply that by 3.3, as you can see down here, to generate what the actual voltage is for that raw data reading. Now notice here what they've got is LCD.locate now 2, 1, which means column 2, row 1, which is on the second row and the third position from the left here. And notice I've split this line into 2 lines just to make it format a little better. This is all one where it says sprintf, buffer, comma, then it gives them some print format information, comma, voltage, and voltage 1. So voltage is going to go into this one, voltage 1 into this, and it's going to create a string that puts into buffer, and then you print the buffer. Because you cannot print it, the print that we've got here for the LCD is like put string. You can only print strings. You cannot print data. And so this little trick that it talks about in the material that you've got in the practice quizzes and the videos shows you how to do this. When you run this program and you turn the pot, you should see the reading, which is the actual reading, the raw data from 0 to 1 showing up here. And at the same time, you should see the equivalent voltage from 0 to 3.3 volts roughly showing up here. Now it says export this video to MCO455 and do the same operations here. Now if you're doing that and you've already run this as you've seen before in an embed, you're going to have to clone it, and then you're going to have to delete the embed library that says documentation not ready and copy the one that says classes in it and then export it to MCO455. And it says watch this video to show you how to set breakpoints and all this stuff here. Now it's going to say modify the program so that you have the following updating on your screen. Now notice it's not just pot and what it is a voltage, it's now pot and temperature, which means you're going to have to dig back from last week and pull up some of the stuff and merge that in with this code to actually show the temperature here in Celsius and the actual pot reading from 0 to 3.33 volts. And again, you're going to use the sprintf to do anything like 0xdf, but make sure that you've used sprintf to put the df up as a degree symbol here. Sometimes you may need to disconnect and reconnect the USB to the LCD to make it work, because sometimes it just gets locked in a certain color. So if you just unconnect the cable, don't disconnect the LCD itself, just unplug the cable, plug the cable back in, USB cable back into your PC, and you should see that this will reset. So sometimes it just happens. Now it says make the backlight color teal. Now if you notice over here, it's kind of hard to see, but teal, where is it? There it is. 008080, and that's what you're going to do, and that's the business of having it saying RGB, set RGB. So the first 2 digits is the red, the second 2 digits is the green, and the last 2 digits is the blue, and different combinations of red, green, and blue will actually make different colors show up on the screen. Then it says further modify this code so it's constantly updated on the putty screen as well. So all this stuff that you see here, and what I would strongly suggest is you put this on row 11 and put this on row 12 and try and center it as best you can to update it on the putty screen. Now after watching this video, click here to import the asynchronous interrupt code into the embed compiler, and click here to import the periodic interrupt code into the embed compiler so you can work with it a little bit, because once you've done that, what you're going to do is you're going to continually modify the code you've got here so that with the use of interrupts, further add to step 10 here, that when you press the left push button on the rising edge, once you push it down, nothing happens. When you let it go, the background color will change to red on the LCD. Also, you're going to add to this code, so when you press the right mouse push button, as you push it down on the falling edge, the background color is going to change to white. So it was some color like teal, but now you can change it to red or white based on which color you want, based on which push button you press. So that's all the modifications you're going to do to this program that's here. Then, right at the bottom here, it says using a separate program and using a periodic interrupt, write a program that displays the following colors, where the colors change every 2 seconds. And the name of each color is centered at the top row. So it'll say red on a red screen, it's centered. It's going to say magenta on a magenta screen. And where are you getting these colors? Again, you're going to get these color combinations from set RGB from this chart here. So red would be FF0000. Let's see, yellow, when you get to yellow, would be FFFF00. So that's all you have to do to make this happen. But it has to happen on a periodic interrupt.